record here and share the screen. All right, so I was going to do, I think, just 4 problems that I had for 6.3, and that'll be done. So the modified assignment is 1 to 27 odd. I did a lot yesterday. So the only ones I was planning to do are 17, 21, 23, and 27. And that's it. And I was going to give you an introduction to the hyperbola, but not do any hyperbola problems, but just sort of get you prepared for it. So I wasn't going to do any problems with the hyperbola, but any introduction I do today would make it easier for tomorrow. Okay? So I will knock off those 4 problems fairly rapidly. And then if you want me to go back and do any of the other problems, we could come pretty close to doing almost literally all the questions if you want me to, because we have that much time. But again, there's a good reason for this also, that I'm kind of semi-slowing down on the schedule so that you should also begin reviewing for the final exam, right? I mean, I say review for the final exam, but as I say review for the final exam, you're still learning new material, right? That's why I can intentionally slow down a little bit here. So as I do less and less new stuff, you go back and review, all this stuff. And again, the way you review is through the old exams, not by literally doing every single question that's here, just the old exams, since the final exam will be stuff similar to the previous exams. Okay. All right, so that's exactly what I have planned. So again, I'm aiming, let's see, I stopped at 15. I'm aiming for 17, 21, 23, and 27. And then if you want me to do anything else, you may. I'll give an introduction to the hyperbola, and we'll probably be done fairly quickly. Okay, so we're here. December 1st, it's already December, folks, so we're done very rapidly if it's already December the 1st, right? So the semester is very much winding down. Okay, so a reminder, I'm aiming for Thursday the 10th for the last exam. So Friday the 11th, I can ask you for a question and answer session, but I'm not promising I'll have your exam finished by then, but I'll try to have the usual video. You know how I make a video for the solution, so you can look at that video and kind of check yourself how to do it. So I'm not promising I'll give you back your test on Friday, but I'll have it over the weekend. And like I said, you've got the test with you after Thursday, and you'll have the video so you can review that. And then over the weekend of this weekend, Saturday the 12th and Sunday the 13th, review for the final exam by just reviewing the previous exams. Okay? And again, for cheat sheets, just compile all the previous formula sheets, and you're hopefully building up, test 6, and just bring them all in for the final exam. Okay, so you have 2.5 hours for the final, 8:10 to 10:40, and then we're done with the course. All right. All right, so I'll get started with the 4 problems that I was going to do. It should not take that long to do, and then I'll let you ask questions. I'll introduce the hyperbola, and then we'll be done for the day. Okay. Again, you can go ahead and put stuff into the chat anytime. I figured out how to see the chat from this view, but anyway, here we go. Okay, so problem 17. Okay, find the equation of the ellipse that satisfies the given conditions. Okay, the foci are plus or minus 2, 0. Vertices are plus or minus 3, 0. Okay, and by the way, that tells me that the center is the origin. So how do you know that? The foci are negative 2, 0, and 2, 0. So halfway is going to be the center, 0, 0. Likewise, halfway between the vertices, negative 3, 0, and positive 3, 0 is 0, 0. So that's the center. Okay, so here we go for that. Okay, so here's 17. Foci are plus or minus 2, 0, and 3, 0. So here it is, negative 2, 0, and 2, 0 are the 2 foci. So halfway between the foci is the center, or halfway between the vertices, or halfway between the minor axis, all of those. Okay, so negative 2, 0, 2, 0, negative 3, 0, 3, 0. Now that tells me that A is 3, right? The distance from the center to either vertex is 3. Little c is 2. It's a distance from the center to either focus. So little c is 2. Okay, so one more time. Distance from the center to either vertex, that's what we call little a. Distance from the center to either focus is c, that's 2. Now I use my a squared equals b squared plus c squared to find b. All right, so a squared is 9, put a 9 there. C squared is 4, put a 4 there. And now it should be easy. Subtract 4. B squared is 5. So B is the square root of 5. Again, you don't need a plus or minus for these. A, B, and C are positive. So square root of 5 is about 2.2. So up and down, I go 1, 2, and a little bit. Down 1, 2, and a little bit. Okay, so this is 0, comma, radical 5. Again, when you're labeling for me, give exact answers. Okay, you use a decimal approximation to know where to point off. I mean, I need to know square root of 5 is about 2.2, where to put the dot, right? So 2.2 tells me I go 1, 2, and a little bit, 1, 2, and a little bit. But when you write it, okay, always write the exact answer for me. Exact answer means leave pi as pi, leave square roots as square roots, leave e as e, leave ln as ln. Okay, just use a decimal approximation, to plot the point. Okay, so a squared is 9, b squared is 5. So x squared over 9 plus y squared over 5 equals 1. That's the equation of this ellipse. And that's it. You're done. Okay, the problem's finished, but I'll dig a little bit deeper. Okay, these 2 points, the 2 vertices, where they're on the ellipse, right? Negative 3, 0, and 3, 0. Okay, let's try out. What happens if you plug in a negative 3 right here and a 0 right here? Well, if you put a 0 here, that's all gone. So forget about it. Negative 3 squared is 9. 9 divided by 9 is 1. So that works. Likewise, 3, 0. Put a 3 here and a 0 here. Put a 0 here, that wipes this out. 3 squared is 9. 9 divided by 9 is 1. Okay. And likewise, let me plug in 0, comma, plus or minus radical 5. Okay. So put a 0 here. If you put a 0 here, this is gone, right? And if you put right here, either a radical 5 or a negative radical 5, right? When you square it, you get 5, and 5 over 5 is 1. Okay. So that verifies that this point, this point, this point, and this point are on the ellipse. There's a whole bunch of other points that work, like all of these. Okay, but they would all have to satisfy the equation right here. The 2 foci are not on the ellipse. They're used to get the ellipse, but they're technically not on the ellipse. 2, 0, and negative 2, 0. And you can tell if you plug in 2 and 0, it doesn't give you a true statement, right? If you put a 0 right here, that wipes that out. But if you put a 2 or a negative 2, that would give me 4 over 9. 4 over 9 is not equal to 1, so forget that. That doesn't work. Okay. All right, 21. The length of the major axis is 5. The length of the minor axis is 3 in standard position with foci on the x-axis. Foci is on the x-axis, so it's bulging in the x direction. Okay, now the major axis is 5. That's 2a. That's the total distance from vertex to vertex. So I have to divide that by 2. Cut it in half. So a is equal to 5 halves. Okay, major axis is vertex to vertex. The minor axis is this entire distance. That's 2b. So I cut that in half. That'll be b. Okay, so the major axis is 5. That means from here to here is 5 over 2. And from here to here is 5 over 2. Likewise, the minor axis is 3. So up and down is going to be 3 over 2, or 1.5. Okay. So negative 5 halves, comma, 0. 5 halves, 0. Up and down is 3 halves. Okay, so 0, comma, 3 halves, 0, comma, negative 3 halves. Okay, so a is 5 halves. Therefore, a squared is 25 over 4. B is 3 halves, so b squared is 9 over 4. Okay? So it goes x squared over a squared plus y squared over b squared equals 1. So A, we now know is 5 over 2. So you put 25 over 4 here. I know that looks funny, but that's considered the standard form. So we'll just leave it like that. X squared over 25 over 4. Okay. Plus y squared over b squared. B squared is 3 halves squared, 9 over 4. Is equal to 1. Okay, and that's it. They didn't actually ask us to find the focal distance C. You can find it if you want to, but they didn't ask for it, so I won't bother this time. But you can just use your a squared equals b squared plus c squared formula to figure that out. Okay, it shouldn't be that bad. Okay, in fact, I think it's going to be 2. But it is bad. That's it for that one. Okay, then 23. The foci are at 3, 0, and 1, 0. A vertex at 0, 0. Okay, the center is not at 0, 0. Okay, a vertex is at 0, 0. So this one's translated. It's a translated conic section. Ellipse. So let's see. Foci are 3, 0, and 1, 0. And a vertex at the origin. So here's what you do. Here's 3, 0. Here's 1, 0. So the center is halfway, 2, 0. So the center is definitely 2, 0. So automatically, if the center is 2, 0, I know it's going to be x minus 2 squared over blah, 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 plus y minus 0, or just y squared divided by blah, 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 equals 1. Okay, so one more time. It's not centered at the origin. Where's the center? Well, halfway between the two foci. And foci, one focus, two foci, F-O-C-I. Okay, so focus here, 1, 0, focus at 3, 0. So halfway, 2, 0, that must be the center. Once I know the center is 2, 0, it's going to be x minus 2 squared divided by something, plus y minus 0, which is y, squared divided by something, equals 1. Okay, so the focal length, C, is 1. Okay, it's the distance from the center to either focus. Okay, again, one focus, two foci. So C is 1. A is the distance from the center to either vertex. They told me a vertex is at the origin, 0, 0. So how far is it from here to here? That's 2 units. So A is 2. And of course, that tells me I can go 2 units to the right also and get the other vertex. All right, so they told me one vertex is at the origin. The other vertex must be at 4, 0. Because now that I know the center is 2, 0, I go 2 units that way for one vertex. I go 2 units that way for the other vertex, 4, 0. How much do I go up and down? I use my a squared equals b squared plus c squared. Okay, a is 2, so a squared is 4. C is 1, c squared is 1, so 4 is b squared plus 1. Subtract 1, b squared is 3. B is the square root of 3. Use your calculator, it's about 1.7. Okay, so I go 1.7 up, 1.7 down, but label it with exact values. So the endpoints of the minor axis are, this was 2, 0, right? So I just go up radical 3, and I go down radical 3. So 2 comma radical 3, 2 comma negative radical 3. All right, so I'm ready for the equation now. I already knew it was x minus 2 squared divided by something plus y minus 0, right? Y squared over something equals 1. So I divided by a squared, and we now know a squared is 4. Okay? And it's going underneath the x because I know it's bulging in the x direction. X minus 2 squared over 4 plus y squared over b squared. B squared is 3 equals 1. Okay? So that's it for that. Okay, and then 27 was the last one I was going to do, folks. So it will take me a few minutes for that. So if you want me to do any other questions now, you can start putting in the chat if you wish. Otherwise, I'll introduce a little bit of the hyperbola, and we're done early. Okay, but that was all I was going to do for today. You can see how we are time-wise. We're okay. Right, so 27. The vertices are 3, 3, and 3, -1. And the graph passes through 2, 1. Okay, so how do you do that? Okay, so here's the key information. I have a vertex at 3, 3, so I plotted 3, 3. I have a vertex at 3, -1. So that tells me this ellipse is bulging vertically. And it touches the point 2, 1. All right, so where's the center? The center is exactly halfway between these 2 points. So here's 3, 3. Here's 3, -1. So here's the point right in the middle, which must be 3, 1. So the center is 3, 1. Okay, 2 units that way, 2 units that way. Once I know the center is 3, 1, I automatically can write this down. Right? X minus 3 squared divided by something plus y minus 1 squared divided by something equals 1. That's a given. We already know that. Okay, because we're translated instead of the origin, we're over at 3, 1. Okay, now how do I do the rest of it? Well, I know the A is 2 because that's how much I go up or down from the center. From the center to either vertex is 2 units, right? From 3, 1 to 3, 3 is 2 units. From 3, 1, go down to 3, -1, that's 2 units. So A is 2. So that automatically means this is a 4. Okay, and I have to figure out the B squared. Okay, so A is 2. Okay. A is designated as a larger number, so that goes here 4. Now I use the information that the graph passes through the point 2, 1. That means I put X is 2 here, Y is 1 here. Okay, now what's all this cross-off stuff? Well, if you put a 1 right here, 1 minus 1 is 0. 0 squared is 0, 0 divided by 4 is 0. So you can pretty much X it out and forget about it because this is 0, right? If you plug in a 1, okay, they told me the graph passes through 2, 1. Okay, so put a 1 right there. That becomes 0. Excuse me. Okay, put a 2 here. So 2 minus 3 is -1. So I basically have -1 squared over b squared equals 1. But what's -1 squared? 1. 1 over b squared equals 1. Multiply both sides by b squared. B squared equals 1. Take the square root. Don't need a plus or minus. B is equal to 1. So I now know that b is 1. So go back and put that here. 1 squared is still 1. So final answer, x minus 3 squared over 1 plus y minus 1 squared over 4, that's a square there, equals 1. All right, that was it. I was going to start the hyperbolas, but I do see something in the chat, so maybe I'll do that first and then introduce something from the chat. Okay, so if you want to start writing stuff that you want me to do, go ahead. Let's see. I was asked for 9 and 19. Try that. And I'm assuming it's from this section. I'll go ahead and make the assumption that it's this section. Okay, so question number 9. Let's see what that's about. Okay, 4x squared plus y squared plus 16x plus 12 equals 0. Okay. So let me write that down and get to work on it. 4x squared plus y squared plus 16x plus 12 equals 0. All right, so throw the 12 over. Put the x's together, leave the y's alone. So put these together, and I'll factor out the 4. So 4 parentheses x squared plus 4x. Leave a gap. Let me double check. That's 4x squared plus 16x. Yep. Plus y squared. Y squared doesn't need to complete the square because otherwise there'd be a y term like plus 8y or something like that. So I don't need to leave a space for that. Equals negative 12. Okay, then I do the complete the square, half and square. So I need half the coefficient of x and squared. So 1/2 of 4 is 2. Square it. 2 squared is 4. Right? So complete the square, half and square. Half of 4 is 2. 2 squared is 4. So plus 4 here, but that's really plus 16. Right? Because the 4 distributes that 4. 4 times 4 is 16, so plus 16 over here. So 4 parentheses, this is a perfect square. X plus 2 squared equals 4. Divide by 4, divide by 4, divide by 4. X plus 2 squared over 1 plus y squared over 4 equals 1. Okay, so there we go. You can read off the center is negative 2, 0. Right? What number makes this 0? Negative 2. What number makes this 0, 0? Okay, so A is 2, B is 1. And let's see. A squared equals B squared plus C squared. A squared is 4. B is 1. 1 squared is 1. C squared. That means C squared equals 3. So C is radical 3. That's about 1.7. Okay. So center is negative 2, 0. Something like that. Negative 2, 0. All right, let's see. Up and down is 2. 1, 2. 1, 2. Left and right is 1.7-ish. So there and there. Be like that. Oh, I'm sorry. Left and right is only 1. I goofed. I was only supposed to go 1 unit. Okay. So I should come to here instead. No. Ignore the outside curve. So that's not really there. Sorry, messed up. Should be like that. So these are two vertices. So vertex 1 is negative 2, 2. Vertex 2 is negative 2, negative 2. That looks like negative 1, 0. That looks like negative 3, 0, the endpoints of the minor axis. Focus it better if I raise it up. Here we go. Negative 2, 2, negative 2, negative 2 are the vertices. And the foci, I go up and down 1.7. So I'll just point to it. So focus 1 is negative 2, comma, radical 3. Focus 2 is negative 2, negative radical 3. And again, focus is better if I raise it up. So there we go. Negative 2, radical 3, negative 2, negative radical 3, negative 1, 0, negative 3, 0. Center is negative 2, 0. Yeah, I think we're good there. Okay. And let's see, what was the other one? Let's see. 19 was asked for. Okay. And again, I'm assuming it's this section. Okay, 19. Okay, 19 foci, 0 plus or minus 1. X-intercepts plus or minus 2, 0. Okay. Quick picture. Two, three, four. 2, 3, 4. 1, 2. 1, 2. Focus 1. Focus 2. And that tells me C is equal to 1. Distance from the center to either focus is little c. And I know B is equal to 2. Okay. I know this is the major axis because that's where the foci are. So I go up and down some unknown value. The B is 2. Okay, so A squared equals B squared plus C squared. That should be too hard. A squared equals B squared is 4. C squared is 1, which is 5. So A is radical 5, 2.2. So up and down 1, 2, and a little bit. Down 1, 2, and a little bit. So it's almost circular. Because left and right I go 2, up and down I go 2.2. So it looks kind of circular-ish. And here are my two foci. Okay, so x squared over plus y squared over equals 1. So in the x direction I go 2. 2 squared is 4. Up and down I go radical 5. Radical 5 squared is 5. So it looks like that's going to be it. Okay. And I had a question from a previous section, I think it was. 6.217. Okay, let me take a look at what that one's about. Okay, 3x squared minus 12x plus 4y plus 8 equals 0. So this is a parabola. All right, so I'll complete the square on this. These two get thrown over to the other side. Factor out the 3 here. 3 parentheses x squared minus 4x. Leave a gap. Negative 4y minus 8. Is that right? Complete the square. Half and square is going to be plus 4. Right, so half of negative 4 is negative 2. Negative 2 squared is 4. So plus 4, but if I distribute, that's really plus 12. Like that. Right, so this becomes 3 times x minus 2 squared equals negative 4y plus 4. X minus 2 squared equals, factor out to negative 4, y minus 1, divide by 3, divide by 3, x minus 2 squared equals negative 4 thirds, y minus 1. Okay, so that's in standard form. So I can read off the vertex as 2, 1. Squared in x, not in y. Negative means it's opening down. That's like y equals negative x squared, right? Okay, so negative 4/3 is negative 4p. Multiply both sides by negative 1/4. Okay, so the standard form is x squared equals negative 4py. There's the y. So negative 4/3 is my negative p, multiplied by negative 1/4. Cancel, cancel. So p is equal to 1/3. All right, so here's my vertex. P is 1/3, opens down. One, two, three, four. 1, 2, 3, 4. 1, 2. Okay, vertex 2, 1. 1, 2, 1. I know it's opening down, so it's going to look something like this. I go down 1/3 of a unit, which is not very much. So focus is 2, comma, 1 minus 1/3 is 2/3. I go up 1/3 of a unit, that's 1 1/3 or 4/3 for my directrix. So directrix y is equal to 4/3. Actually, I made it too high. It should be a little bit lower, but anyway. So it gives you enough space for that one. Okay. All right, let's see. What else is there in the chat? I think that's it. 9:45. Okay, I'll give you a quick introduction to the hyperbola, and then we'll call it a day. Okay, so I'm finished with the ellipse. We now have the hyperbola. Section 6.4. So we're down to our last two sections, folks. We're finishing up very rapidly. So what's happening for the hyperbola now? Let me show you the standard form for the hyperbolas. On page 338, hyperbolas look either like this or like this. Okay. Opens left and right, up and down. This is the actual hyperbola. That box, which you're going to draw for me, that's not part of the hyperbola. The asymptotes are not part of the hyperbola. The blue stuff is the actual hyperbola. Okay, x squared over a squared minus y squared over b squared equals 1. So notice that looks exactly the same thing as the ellipse, except instead of a plus, it's a minus. Okay, if x is positive and y is negative, it looks like this, left and right. Up and down, y is positive and x is negative. Okay, and it might be better if I show you this picture right here. Oh no, that actually doesn't help, sorry. Forget about it. Y squared over a squared minus x squared over b squared equals 1. So here's our only instance where y comes first. Okay, in the hyperbola, and there's a minus here. Now for the ellipse, we didn't turn it around because if you have a plus, then if x squared comes first or y squared comes first, it's the same thing. Since addition is commutative, you can change the order anytime you want. So we usually just leave x squared in the front and y squared in the back. Not so for subtraction. So this is different. Y squared over a squared minus x squared over b squared equals 1. That's going to be going up and down. And it'd be nice if they were on the same page, but it isn't. Okay, so this type, x squared positive, y squared negative, looks like that. If you switch it, y squared positive, x squared negative, it goes up and down. Okay, you will draw the box for me, you'll draw the asymptotes for me, and then the actual graph. Okay, so I'll be showing you how to do that. And let's see. Maybe they give me a nice summary here. Unfortunately, not too much. So let me go ahead and show you this. Top of P38, standard position hyperbolas. So it looks just like the ellipse, except it's a minus. X squared over a squared minus y squared over b squared equals 1. Or switch it around, y squared over a squared minus x squared over b squared equals 1. Okay, so again, if x is positive, y is negative, left and right. Put it on your cheat sheet if you wish. Y is positive, x is negative, up and down. Okay, and the other thing I need to emphasize here, the designation of A and B is A goes with the positive, B goes with negative. This time you don't look at which is the larger number. Okay, A might be bigger than B, A might be less than B, they might even be equal. It doesn't matter. Okay, the A designation is for the positive, B is for the negative. I suppose you could argue, well, since this is positive and this is negative, any positive number is bigger than any negative number. So if you want to think of it that way and saying, okay, A is always going to go with a larger number in some strange sense. This is always going to be larger than that because positive is always bigger than the negative. Okay, so anyway, this might be 9, this might be 25. We're still going to call that the A is 3 and B is 5, for instance. Okay, now these are true, but the way I'm going to write it is with the Pythagorean theorem, sort of. Okay, if you square both sides and do a little bit of algebra, it's a squared plus b squared equals c squared, okay, what you normally thought of with the Pythagorean theorem. Okay, so for the hyperbola, I'm not writing it down now, but I'll write it, next time since I'm just doing introduction. For the hyperbola, it's sort of like the Pythagorean theorem. A squared plus b squared equals c squared, where c is the larger number. Okay, if I can show you this picture over here. Okay, this is from the center to the vertex. That's A, so in this case it's 3. This is from center to a focus. In this case, it looks like it's 5. Notice C is bigger than A. C will be the biggest number now for the hyperbola. So if C is the biggest number, we're back to Pythagorean theorem. A squared plus b squared equals c squared. Okay. So just like the ellipse, the number underneath the x will tell you how much you go left and right. The number underneath the y tells you how much you go up and down, but instead of drawing an ellipse, you're going to end up drawing a box. Okay, so you draw the box, you draw the diagonals. You don't have to write any of this down. I'm just blabbing, doing theoretical stuff. Okay. And then you decide, does it go left and right or up and down? See, x is positive, it goes left and right. If y were positive, then it would just go up and down, and I'll show you how that's going to work starting tomorrow. Okay, but what are we up against? Hyperbolas. Okay, notice they're all minus signs. Sometimes y is in front, sometimes x is in front. That's different. Looks like we have to complete this square, and there's other stuff going on there too. Okay, so we'll do that reading tomorrow. All right, so I think I'm done, folks. Let me check the chat. I think that's about it for the chat. So we're finished. All right, folks, that'll do it for today. All right, so tomorrow I'll get started with the hyperbola and go from there. All right, so have a good day, everybody. We're done. See you tomorrow. Bye, everyone.